Hello Internet, welcome back to our voxel terrain. In this video, we are going to actually be blowing things up, which is going to be super cool, and it's going to be fun. So what we need to do is, there's two parts to this. The first is we're going to make it so when we click the mouse, we can toggle the terrain at that point. So like left click will be destroy and right click will be create or something like that. And so we can both add and remove from our voxel terrain. The next part is to fix our bug, which as you can probably not see very well, but we have a little bug where in our mesh creator, we aren't checking if the value of the node. So we're just making one. And what that is causing to happen is what we had previously. So we don't have any checks for the actual value, which is why our final node is more or less ignored. And if we have a leaf node, we draw it, which is why the actual picture here is not as high resolution as it should be. So we'll fix that. And then if we have time, I want to do a circle destruction. We may have to push that back to the next one just because I think just drawing is going to take some time, and we'll take our time with it and get, because the circle is going to take some. I've got an algorithm worked out for it, and I think it's going to work really well, and I think it's going to be cool. But it's going to take some time to get implemented, and I don't want to turn this into like an hour-long things, and then you guys get stuck halfway through and go and do something else. So we're going to start and try to keep this short, and then get this done, and then see where we are after that. So let's get started. We have this. What we need to do first is, I talked about there was a bug, and that is here. So for each leaf node, we're doing all of this stuff. What we want to do is find each leaf node where something, what was it going to be? Where the node, is it not going to let me do that? It should let me do that. Come on. Where the node dot value, because it should be a boolean for the value, so that should work. I don't know what's wrong there. Generic, we are missing link. So let's throw in link here. There we go. And now we just need to find our value. So where was it? We're getting our leaf nodes, which is going to be a quadtree node. We called it data. Of course we called it data. Why would we call it value? I think we had a good reason for not calling it value, and I think it was because of the setter and that conflict. Anyway, this is a link statement, so it means we're going to take this list that we're getting out of here and only take the ones where the data is true. It's a boolean value, so we can just keep it at that. So I'm going to need to restart this, and now we should get that, and we should generate, and we'll actually get, you can see we get more definition. We're still off by 1, which is annoying. Huh. We can fix that. This was supposed to be less than or equal to. Didn't we? We already fixed this, didn't we? Did I not save? I may not have saved. Anyway, there's one more cell, if I remember correctly, than we had previously. And so we need to actually add them. And that should complete our cell. There we go. So now we have our full image. What we need to do now is we need to convert our mouse coordinates on our screen into coordinates in our world space. So we're going to actually convert them, take the screen coordinates of our mouse, convert that into world coordinates, and then project array. Luckily, Unity makes that super easy. They actually already give us a component to do that. So what we're going to try to do is we're going to hook this up so we can update our quad tree. The issue is that's not going to update our mesh. So we're going to have to do those in two separate parts. So we may be able to update our quad tree right away, but updating the mesh is going to require a little bit more. So let's walk through and see what that's going to look like. Quad tree, we'll call it just the quad tree pencil. And we capitalized it there because I wasn't paying attention. And so now we have two totally different naming standards. We're doing a great job here. So what do we want? We want to add and remove, but first we're going to want a reference to our quad tree component. I said I was going to fix IntelliSense. I didn't fix IntelliSense. Oops. So that's still broken, so we're going to be guessing again. Great. So we have that. Our quad tree is going to connect up to our other quad tree. That way we can actually talk. I was talking with somebody else. I believe it was, who was it? Anyway, what they're doing is they're doing a get component and actually requiring it here. This way, I'm considering throwing this on our camera instead of here. Once we get everything kind of sorted out where we want it, I'll probably condense it down into something that makes a little bit more sense and kind of forces you into a pattern so you don't end up throwing things all over the place. But for now, we're going to keep it this way just because I don't actually know where this is going yet. So we're kind of making do with what we have. So we have our update, and we want to do a camera, and we want to grab the main camera. So what the main camera is if I go back to Unity, it's called the main camera here, but that isn't how it finds the main camera. The way it finds the main camera is the one that has the main camera tag. So there are all these tags here, and if you go, where is it? What? Okay, anyway, so there's all those tags there. Some of those are default, all of those are default, and you can't remove those. The main camera is going to flag which camera is your main one. So that's what's used in these scripts. We're just going to tie directly onto the main camera because that's all we really care about right now. And then there is a world to viewport point. Viewport point to ray is what we want. And so this is going to take our mouse position and it's going to translate it into a ray, which we can then cast to our 0 plane, our plane of our quad tree, and then use that to actually draw. The cool thing is I believe, unless I'm very much mistaken, we're actually using we are using a orthographic camera, which means the frustum is a rectangle. It's just, well, actually I can show you that. So if we go into 3D view here, this box, it's called the view frustum, and I think I may be pronouncing that wrong, but the idea is this is actually what you'll see. So here is where we're projecting from, and we're projecting all the way down there. And so orthographic means there's no scaling, so there's no perspective. Normally in 3D you'd have a perspective camera, and you can see it starts much smaller. It actually starts at a single point, and then it goes out from there. And so that's sort of your perspective view, and that's going to make, as things get further away, they're going to appear smaller. With an orthographic camera, that isn't going to happen. Things that are an inch in front of your face are going to look as big as if they were like a mile away. So because of that, nothing's going to change. So if we get our viewport point, if we get our ray, the point that its origin, that X and Y, that's not going to change if we project that wherever we are. It's always going to be the same. We don't need to change it. We would have to do some work if we were using a perspective camera, and we'll get into that. But for now, we can kind of cheat and pretend like it's just fine. because it is. So this is going to be our insertion point. I don't really like that name, but we're gonna roll with it because why not? Then we're gonna do an input dot get mouse. What is it called? There's a get mouse button. We're gonna have to do a bunch of inspecting just because IntelliSense is gone, and that's just how I find things. So mouse button 0 is going to be your left mouse. It's going to be your primary button. I suppose probably with a left-handed mouse, if you have a left-handed mouse, that'd actually be your right side of your mouse, whatever your primary is set up as. Or if you're malicious and switch it on your friends when they're not looking, then it's probably the right side. But anyway, that's going to be your primary mouse button. And so when we have that, we're going to do a quad tree, and we want to get the quad tree from there. So let's dig into this. And then we just want to insert at our point with the value. So this is actually super easy. Insertion point. And that's just, we can just plug that in. It'll automatically convert it to a vector 2. And we want to just say that's actually false. So that will delete cells. And then this can be true. And so we'll pull this in. If our input mouse button down, or just mouse button actually, and then we'll do that. And so now we have our insertion points. It really doesn't like that. That's because that's array. That's not right. This we want to be our position. I may be screwing things up a bit. What is it? Origin. That'll work. That won't. All right. Our dot origin and our dot origin. And so this is actually going to allow us to draw, because these get mouse button are going to return either 0 or they're going to return false if it's not down. Otherwise, they're going to return true if it is. And they'll just keep doing that. So we can hold it down and draw. It'll be just like Paint's pencil tool. We aren't going to be regenerating our mesh every time. We're going to have to manually do that. But I don't think that's going to be a problem. We'll find out pretty quickly if it is. So we actually should be able to test this now. So I'm going to up the threshold so we barely get anything. And that way we'll have mostly a sparse quad tree, and we can actually insert things, and we should see it actually build itself out as we start inserting things. So I can start this, we'll generate, and then I can click. That was supposed to work. Clearly, we need to do a little bit more. So what do we need to do? Why wouldn't that work? Interesting. I'm confused why it wouldn't throw an error, but also wouldn't work. That's confusing to me. So we're gonna just quickly log this out. Deleting, I guess we'll say. And I'm actually going to throw out the insertion point dot origin. And so we should be able to use this to kind of figure out where things are, just so we know roughly the positions we're trying to insert at, in case it's like wrong. Okay. I don't know if you can see that, but the XY is 7,752 and 3,085. Yeah, that's not right. Well, that's way wrong. What did we do? We've done something horribly wrong. Viewport point. I don't think that's right. I think we chose the wrong thing. There's a way to get the ray, and I don't know what it is. So let's search for something with a ray. Screen point to ray. You know, that's what we wanted. So, screen point to ray. There we go. That should work a lot better. Yeah, cool. And it is working. So you can see, like here, we've got all of that. So if I drag this, we can actually insert some points. And then, since those were actually deletes, so if I hit generate again, it's not going to do anything. But if I come over here and say, like something like this, I should be able to regenerate that, and we get some points. So we get some more, or we get high. I spelled that poorly, or it didn't look great, but you get the idea. We can kind of edit this, which is sweet. So now what we need is we need a way to tie in quadtree updates and our mesh generator. So we want, I think we can use an event system for this. And so what I want to do is I want to tie in this quadtree component and then have it automatically fire off an event that can be listened to by, say, this mesh creator. And then that can actually regenerate our mesh every time it changes. So how are we going to do this? There's a quadtree component. We're going to jump into our quadtree. And for now, what's the best way to do it? Let's just make a new event. So we'll do a new public event with an event handler. Oh, does that not work? Why doesn't that? Oh, it's not imported. Got it. Found it. And so this will be quadtree updated. So we've got a new event for our quadtree updating. And we are going to just make a quick private function, which is going to be notify quadtree update. And so all this is going to do is just send a message out and say if our quadtree updated, then we want to do a quadtree updated dot. We can actually just call it. So there's invoke. I was actually just talking about this in a comment earlier, which is kind of why I'm covering it now. So there's an invoke, or you can just do this, and it should do the same thing. You need to pass in this and new event args. And so we're not going to be passing any event arguments right now. Ideally, we'd actually pass in sort of what nodes need to be updated just so that we can actually do that. And we just need to check that this is not null. And so we should be able to notify our quadtree update at the end of our insert. And so every insert, we should be able to do this, and then it should just be magic, I think. So that's going to call that event. And then what we need to do is hook in our mesh creator. And so this, in our start, let's grab our quadtree. Where is our generator? Also in the start. So for our generate, no, let's just tie right into it. So quadtree. How do we want to do this? So what I'm trying to figure out is these are both going to happen at about the same time. And so we've run into this issue before where things try to happen in the wrong order. and we're going to run into that again here. So I'm trying to figure out how to do, or how to handle that, because what we want to do is do something like this, which will be our object and then our args, and we just want to say generate equals true. That's all we want to do, but we can't do it here because our generation of our actual quad tree is happening in the start as well. So we need to follow that up somehow. And I don't know the best way to do that. Let's actually, I don't like this at all. But for now, I should figure out a way to solve this. That would be a good idea. Because this idea I'm thinking of is really not a good idea. Not even close to a good idea. So if we store our quad tree and just have it be quad tree reference, what we can do, do I want to do that? No, we'll just do a boolean. Bool initialized. Sure. And then if our quadtree is not null, I don't like this at all, is equal to true, we'll initialize it, and then we will assign our event. So this should only fire once, and then it should be done. And what this is going to do is when our quad tree is updated, it's going to say regenerate our mesh, which isn't going to be enough. We are going to also want to store a reference to our previous mesh. And so the idea here is after we generate this whole mesh, we are going to save the chunk like that, and then when we're going to generate it, we'll generate the mesh, iterate through all of that, stop that, and then we can't do that. Sorry, getting ahead of myself. We can't do that because we just set it here, which we didn't want to do. And so instead, we're going to return it out of this function, and then we can actually we can better control it. So this now returns our generated mesh. And so we actually have a reference to that now. And so if our previous mesh is not null, then we want to destroy it, like so. And then we want to set our previous mesh equal to our generated mesh. And this is all coming after our stopwatch has ended, because we've already generated our mesh. That's the only thing we're timing. And so that should be enough to actually get us working. So it should be constantly regenerating as we draw. And it is. I was holding the wrong mouse button. So we can kind of do whatever we need to and kind of, draw. And it's actually, we can actually figure out how fast this is going. It goes at about, looks like 70 frames a second we're running at, and I'm recording a video at the same time. So it's not great, but keep in mind, we haven't done like threading or anything like that. There's nothing fancy going on here. We're literally regenerating a mesh for every insertion, which is pretty cool. It works fairly well, actually, especially considering how bad our mesh generation algorithm is. That needs a lot of refinement, and we haven't really done any of that. So for where we're at, it's actually running pretty well for me. So that's taken about 25-30 minutes. So I think we'll probably cut it here, and then tomorrow we'll pick up and actually get the boom going. And so it's going to be kind of like what we're doing with the pencil here, but we're going to actually do a sphere, or not a sphere, we're going to do a circle. It's 2D. And so we need to figure out how to actually detect where that sphere overlaps and what nodes in our quad tree it overlaps. And then that way we can actually simulate explosions and things like that. And so that should be a lot of fun. And then once we get that, we can actually start texturing this and doing a bunch of other things. Speaking of texturing, give me a few seconds and I will actually show you what this looks like textured, and then we can actually sort of see what this will actually look like. So one sec. So this is sort of how the texturing works. So I have a like rock texture going on. And so what it's doing is it's actually tiling it every unit or so. And so that way this texture isn't that big, it's tiny. And so it's just repeating over each of those elements. And that's causing it to actually look all right. And so I think we'll actually have to end up creating a shader for this to actually sort of blend multiple things. I don't know how that'll all work yet. I haven't gotten that far. But the idea is we're going to need some way to actually signify what all of these things are. Eventually, those booleans that we're using currently for our tree, those are going to go away. But what we can do now is sort of just draw here and get most of what we need, so we can kind of fill things in or take them out and do whatever we need. So yeah, that's where we're at. So the next thing, like I was talking about, we're going to blow this up, and then we're going to actually start marching squares and get them smooth and awesome looking. So that's next. But for now, that's it. So if you guys have any feedback, let me know in the comments. I'd love to hear it. If there's anything you think we should change or ideas you have, I'd love to hear those as well. So let me know, and until next time, see you, Internet.